Okay, for our twin problem, ask the factor four x to the seventh y to the eighth minus ten x squared y to the fifth plus six x to the ninth y to the seventh. Now you can tell by inspection that two is the biggest number that'll factor into 4, 10, and 6. So you're probably going to want to have a 2 out in front of it. And well, we also have at least an x squared in every term. Okay. So we have an x to the seventh here and an x to the ninth here. X squared is the lowest power of x that's common to all the terms. So we're going to be able to factor that out. Then let's say we've got y to the eighth, y to the fifth, and y to the seventh. The least exponent is 5. The y to the fifth is the lowest power of y. Then we ask ourselves, what would we multiply by this to get this? Or if you like, how do we divide this with this? Okay, it's the same question. Well, if things as 2 goes into 4 2 times, we better have the 2. So we multiply the 2 by the 4, right? And then what do we multiply by x squared to get x to the seventh? Well, we're going to have to multiply x to the fifth because we add exponents when we multiply. Or if you prefer, you can think, well, divide x squared into x to the seventh, we get x to the fifth. You divide by the power, you subtract it. You can look at it either way. You should actually be able to look at it both ways. Sometimes it's easier to look at it one way than the other. And you should understand that those two ways are equivalent. In any case, that y to the fifth, y to the eighth, we need 3 more powers of y. You got y to the eighth. Now remember, this comes down to the fact that this means we got y times y times y times y times y times y. Yep, that was 1 2 minutes. But there are 5 of them. And we got to get 8 of them. That's y times y times y times y, y times y times y times y. Okay, you write it out. You see, we need 3 more y's on y to the fifth to get y to the eighth. You also want to be able to look at it that way, just to make sure your thinking is consistent, because if you forget the rules for exponents or aren't sure you have the rules for exponents, you can always go back to the basic thing as we presented it when we first looked at it, okay? Which is, how many y's do you have multiplied here? How many y's do you have multiplied here? How many do you need to multiply by this to get this? One way or another. Gonna see that's y to the third. And then okay, 2, you can actually say, well, why to multiply by 2 to get negative 10? Well, answer is pretty clearly negative 5. But of course, you can divide negative 10 by 2, you're going to get negative 5. So with the 2 times negative 5 gives you negative 10. We've got x squared, we need x squared, so we don't need any x's. We've got y to the fifth, we need y to the fifth. So when I multiply negative 5 by 2x squared y to the fifth, we're going to get negative 10 x squared y to the fifth. So that works. Then we're going to have plus 3. 6 divided by 2 is 3, 4. What do you multiply by 2 to get 6? You multiply 3. Okay. Then x squared, x to the ninth. We've got 2 of them here. We're going to need 9 of them here. It's going to give us x to the seventh. And a y to the fifth, y to the seventh. We're going to need y squared. Then we check it using the rules of exponents, because we want to reiterate this. Check. Yeah. 2x squared y to the fifth times 2x to the fifth y cubed plus 2x squared y to the fifth times negative 5 plus 2x squared y to the fifth times 3x to the seventh y squared. Is that equal? Well, that's 2 times 2 times x to the second times x to the fifth times y to the fifth times y to the third plus 2x squared, well, 2 times negative 5 x squared y to the fifth plus 2 times 3 x squared times x to the seventh times y to the fifth times y squared equals, well, x squared is 2x's multiplied by each other. X to the fifth is 5x's multiplied by each other. It gives you 7 of them. And you know how to write that out. Okay, of course, 2 times 2 is 4, but x to the squared times x to the fifth is x to the 7th. We add the exponents because the exponents tell us how many of this we write out, and how many of these we write out. So we add the exponents, we get x to the 7th. And now I'm just going to go with adding exponents. Y to the fifth times y to the third is y to the 5 plus 3, which is y to the 8th. Then 2 times negative 5 is negative 10. That's all we have to do to this term. Then we have 6. X squared times x to the 7th is x to the 9th. Y to the fifth times y squared is y to the 7th. Does that match what we have up here? There's 6x to the 9th, y to the 7th. There's 10x to the 5th, 10x squared, y to the 5th, 4x to the 7th, y to the 8th. Okay? So now we're sure we did it right. Now let's go to the problem. Plus 4. These things are taller than ones, so they're absolute value signs. Okay? Because you could easily read that as 1x plus 21, right? Especially sitting way in the back of the room, not mentioning any name. Okay. But yeah. So we solve that by saying either x plus 2 equals 4, because if x plus 2 is 4, then the absolute value is 4. Absolute value of 4 is 4, right? But also the absolute value of negative 4 is 4. So we can write x plus 2 equals negative 4. Can do that. Significant number did. Okay. But don't do that, because that'll test it. You solve an absolute value equation. If you try to subtract 2 from both sides of this, you can't do that. That 2 is stuck inside of this absolute value. Okay? Just doesn't work. If you do that and check, you're going to find that you got the wrong answer. Okay? Which is why you always check, because if you check, you can make sure that you're pretty sure that you got the right answer. It's possible to make a mistake in solving the problem, then make some other mistake in checking it and think that you got it right. But 99% of the time, if you check and your answer is wrong, you're going to find out that it's wrong. Okay. You always want to check. I'm talking a lot about how you have to learn this stuff. Don't just slop something down, hope it's right, put it in open math, it isn't right. Take a 20% hit and you try it again. Okay. It's not a good way to prepare yourself to show that you know what's here. Okay. Like taking an example or whatever. Okay. So back to the problem itself. This problem splits into these two for a reason that's pretty obvious. Absolute value of what equals 4? Absolute value of 4 or absolute value of negative 4. So x plus two is gonna be four, or x plus two is gonna be negative four. Okay, well, then, solution, I'm not gonna write out the details of the solution. Subtract two from both sides, you're gonna get x equals two. And here you're gonna get x equals negative six. And you check. X equals two, absolute value of x plus two equals absolute value of two plus two equals absolute value of four, which is four. So this solution checks. We've got another solution with x equals negative six, absolute value of x plus two equals absolute value of negative six plus two equals absolute value of negative four, which is four. So this checks and this checks. So we're sure we have the right solution. And we're sure we have all the right solutions, because if x plus two is anything but four or negative four, its absolute value ain't 34. Okay? Make sense? So we really want to understand that. And I think I didn't camera over. I think I got everything. Let me just take one little camera moving, and we'll be sure. Okay. Now, the third problem is solve x plus five less than or equal to four x 7. We subtract 5 from both sides. And get 3x less than or equal to 4x minus 12. Then we subtract 4x from both sides, because we've got to get all our x's on one side. We get 3x minus 4x less than or equal to 4x minus 12 minus 4x. 4x minus 4x is 0. That leaves us negative 12 here. It leaves us negative x here. Okay. Now we multiply or divide by negative 1 in order to get x. Because we've got negative x. We don't want to know what negative x is. We want to know what x is, right? I did something wrong when I did that, but I multiplied both sides by negative 1. So what could I have done wrong? Well, it's very easy to treat this like it's an equality, but it's an inequality. If you multiply or divide by a negative, you got to reverse the inequality. So that finally we see our solution is x is greater than or equal to 12. And we can put that on a number line. We can choose to put x equals 12 there, and the solution will then include 12 and every number to the right of it. Make sense? Okay, well, that's a review of a couple of things that I saw frequent mistakes on the midterm. So take a lesson, and we'll do more with that later on. Okay. Now today, I believe, and let me just look, because with the pre-calculus and pre-calculus support and pre-calculus courses, I can easily get confused about what I'm doing on what day. So I just want to keep myself straight. I'm going to take a quick look at my thought. multiply x plus 4 by x plus 7, we get x squared plus 7x plus 4x plus 28, right? And the 7x came from multiplying 7 by this x. The 4x came from multiplying 4 times this x. Okay, so we want to keep that pattern in mind. And I want to, and of course, that equals x squared plus 11x plus 28. Now let's start with one of the easier ones. X squared plus 5x plus 6. We suspect that that's equal to x plus something or maybe minus times x plus or maybe minus something else. Now I'm going to say from the beginning that open math gives you all kinds of tricks and formulas you can use to factor things. Okay, I find that people usually don't remember those tricks and factors, those rules, when they get to the exam. Okay, so I'm going to do this just basically by trial and error, because it's possible to do. And then you get one where you really need formulas and tricks and factors that open math gives you. Well, hopefully you'll know those too. Okay, but most of them you're going to be able to do one or do. Okay. Well, I can put x plus or minus some number here and x plus or minus some number here. What do I know about these two numbers? Well, if I multiply them, they're going to give me 6. Right? Like, how did I get the 28 here? I multiplied this number by this number. Okay. So could be 2, could be 3. And I'll put a plus or minus there just to indicate that this number could be positive or negative. This number could be positive or negative. Okay. Now, if this number is positive and this number is negative, I know darn well I'm not going to get 6 because a positive times a negative is going to give me a negative, right? So if this one's positive, this one has to be positive. So this means I've either got x plus 2 times x plus 3 or x minus 2 times x minus 3. Does that make sense? So I can check that out. Okay. Well, since all my signs are plus, I'm just going to make a wild guess and say maybe I've got x plus 2 times x plus 3. Okay. If I multiply that out, am I going to get this? Well, by now, we should be able to look at the binomial and see that, yeah, I'm going to do x times x, that's going to give me x squared, right? Then I'm going to do x times 3, just, you know, and I know that the distributive law is going to lead me to do x times 3. Okay, and that's going to be 3x. And then I'm going to multiply this x by 2, and that's going to give me 2x, which is going to give me 5x, right? And then 2 times 3 gives me 6. So I should be able to look at a trinomial with what we call a monic trinomial with coefficient 1 in front of x squared. How to verify whether write it out. Our check is just to continue this multiply it out, show that it actually started. Okay. Now let's try. X squared plus 6x minus 8. See if we can factor. I'm not going to guarantee we can. Let's see what we might try. This could be plus 8 times x minus 1 is a possibility because that's going to give us x squared. It's going to give us negative 8, right? This gives us a plus 6x. No, because the 8 times x and the negative 1 times x will give us 8x minus x, which is only 7x. If that was 7x, we'd have hit it. Okay? But this gives us x squared plus 7x minus 8. Okay? Now, we could try a could be 4 times 2, right? So we could try x plus 4 times x minus 2. We wouldn't try x minus 4 times x plus 2. Why not? Because the 4 would be, the negative 4 has a bigger magnitude than the 2 would. The negative would be bigger than the positive, and we'd get a negative coefficient of x. So if you understand that, okay. Otherwise, you'll discover it if you around visual. Okay, is that going to work? You look at it and see whether it works or not. Now we've already guaranteed because we chose 4 and negative 2 because they multiply out to negative 8, right? So we know this term is going to give us a negative 8, and we know that x times x is going to give us x squared. So all we got to do is figure out what the coefficient of x will be when we multiply these. Well, we know we're going to have 4 times x for this, and we know we're going to have negative 2 times x here. Well, 4x and negative 2x gives us negative 6x, right? And that, I mean, gives us 2x. So this gives us okay. Well, at this stage, take it clearly, we might as well give up. There's no point in trying x minus 1 times x plus 8 or x minus 4 times x plus 2. And if you're not sure about that, go ahead and try it. You'll see why it didn't work, and next time you won't. Next time you will. Okay. So this one doesn't happen. Let's try x squared minus x minus 6. Write down some possible product where these two numbers multiply out to this one, and of course, you'll have an x in both. So I'm going to put an x here. Here, then I'm going to fill in the number here and a number, a plus or minus in each case. Matter of fact, what I want you to do is write down every possibility you can think of, whether you think it's a good idea, a good possibility or not. every way you can get a -6 over there. Okay. One possibility would be x minus 6 times x plus 1. Turns out that's not going to work, but it's a possibility that we would want to at least think about. Okay, because we just need pairs of numbers to give us -6 when we multiply. This times this gives us -6. So whatever number we have in the middle here, whatever coefficient of x, it's got to come from two numbers and multiply out to -6. Now, if I do x minus 6 times x plus 1, why does do, well, do x plus 6 times x minus 1. 6 and 1, 6 times 1 gives us 6. And if we have different signs on the 6 and 1, we're going to get -6. Now that's two ways to get different signs. And then we have x minus 2 times x plus 3, or x plus 2 times x minus 3. Those are four possibilities. And they're the only four possibilities if we're going to factor this thing with integers. Okay? Because we're not going to try to factor these things with fractions. There's an easy way to factor using the quadratic formula. But that's overkill. Okay? But in some cases, it's necessary. So these are the ways that we check out to see whether this works. So figure out which one of those works. Write it out, multiply it out. And if you're not sure which one works, start with the first one, use the distributive law, see what you get. And then do the second one, and the third one, and the fourth one. Okay, now working on this problem here. Everybody multiply all of these out. And if you do this, multiply this and this and this and this in order, you find that this is the one that works. And everybody found that this is the one that works, okay? I did want you to multiply all of these out so you see how things you see how the structure of this thing links to the structure of this. Then you see how the numbers connect. Okay. So if you haven't multiplied all these out, you really ought to do that. Now, your homework is going to be on trinomials. Trinomial means a polynomial with three terms, trinomial. And usually it means a square, an x, and a number. Okay. That's not always, but usually. Okay. And that's what it's going to mean in your homework. You can always list all the possibilities. You should always be able to list all the possibilities. If you haven't been able to factor it, you should go back and make sure you've listed every possibility. But pretty soon, if you do that, you're going to develop an instinct. You're going to say, okay, I want to get a minus x here. It doesn't make any sense for the plus number to be bigger than the minus number. So you would rule out this one, and you'd rule out this one. Okay, in both of these cases, plus number that's multiplied by x is greater than the minus number. Okay, has a bigger magnitude. Okay, So you could narrow it down to this possibility and this one. And then you can look at this and say, well, the negative 6x is going to be way bigger than the 1x. It's not going to be just a negative x. And that's the only one that makes sense. And then you don't have to multiply them all out. I think it's a good idea to multiply them all out. That's how it works. Also to reinforce the distributive law, because although everybody seems to do fairly well with the distributive law, I've seen some mistakes. Okay. And if you've made some mistakes with the distributive law, you need more practice. And this would be good practice. Okay, let's look at this one. How many possibilities are there? Well, there's x minus 1 times x plus 36 and x plus 36 times x minus 1. Now, is either of those going to work? It's not possible that they're going to work because in both cases, you got a 36 or a negative 36 multiplied by x. And actually, that's where I wanted to plus 1x minus 36. Okay. You got 36 multiplied by x, and then just a 1 multiplied by x, and it doesn't matter which one has the positive sign, which one has the negative sign. You're not going to get 5 out of that. 36 and 1 can't be combined in any way to get 5. So then we try x minus 2 times x plus 36 and x plus 2 times x minus 36. Now, actually, I wouldn't bother writing this one down because the plus 36 and the minus 2 are going to give you a positive coefficient of x. If you see from the distributive law that's the case, you can immediately dismiss the ones where the positive number is bigger than the negative number. Okay. X plus 3 times x. I'll keep these things the same scheme. X minus 3 times x plus 12 and x plus 3 times x minus 12. Now things are starting to get a little more reasonable when you combine these numbers, but you're still not going to get a negative 5. Then you write x plus 4 times x minus 4 times x plus 9 and x plus 4 x minus 9. Well, if you know what you're looking at, and you will, if you do this, within a few problems, you'll know what to look for. You're going to see that this one works. But you have to list all these up to this point. Okay, then x minus 6 times x plus 6. And it would do any good to write x plus 6 times x minus 6 because it's the same thing. Okay, x plus 6 times x minus 6 is the same as x minus 6 times x plus 6. Okay, so since 36 has a lot of factors, 36 can be divided by 1. Every number can be divided by 1, so you don't want to forget that. And it can be divided by 2, and it can be divided by 3, and it can be divided by 4, and it can be divided by 6. Now, the next number that you could be divided by would be 9. But we've already done plus 9, so there's no point in going fast here. But yeah, we could say, okay, well, let's try the next number, x minus 9 times x plus 4. But already we did that. Or we already did that here. Already done here, so we don't need to do it again. Okay, we've already got 9 and 12. And oh man, I didn't do 18. Oh, wait, yeah. 36 is not 2 times 36. 36 is 2 times 18. So what's the thing? When I wrote that down, you gotta be careful. There'll be times you write down things when you're not thinking, probably not as often as I do. Okay? Yeah, do you understand what I'm saying? You understand this word? Now, open math is gonna give you a slick little formula. We don't have to do this. I don't think you're gonna remember that formula for very long after you do your assignment. Okay? Because I don't think most of you in any group would remember that easily. Okay? This is a process, if you do it a few times and write it out, do it in detail, it's going to stick with you. Okay? So my bottom line is it's easy to do your open math in a way that you're not going to remember later. You just use that little formula. That's almost the same, just going to the internet and write down the answers they get. Okay? I don't think it's going to work. If you understand where the formula comes from and how it's derived, that might stick with you. But I don't find that people remember things like that often enough for me to do it in class and waste your time on. Okay? This process is sufficient, and it also gives you a better sense of the numbers. It helps you build number sense, which I think everybody pretty much needs to because of overuse of the calculator in K through 12 and beyond. Okay. So there it is. That's the process I want you to use. Um, when you get into things like this, we got something besides a 1 in front of the x squared. Well, we're going to deal with that a week from today. Okay. And there is a formula that nobody ever is going to remember past the time when they do it. And there is a way to write it out like this, but it gets pretty complicated. There are a lot of possibilities, and we're going to see it both ways, but we're going to leave it until then. Now, the other thing that I'm going to have you do though for next time is to factor using special products. Now, everybody, I think, did the assignment on special products without using the special products because, and it is my fault. I didn't notice that the videos for factoring these things didn't use special products at all. So if you went by the videos, you weren't going to use the special products. Okay. And that's what everybody seems to have done. And I don't have any criticism of you make on that. I don't have anything to suggest that cause you to notice that, well, we do it this way. Okay, but we did derive the special products. We talked about it last time. I'll just write it down. Usually they're written with A plus B. The first time I did it, used X and Y. Like, it doesn't really matter what symbols you use. I think these are the ones that are going to be most familiar, so probably a better idea. So you have these two formulas. How about this now? Factor x squared minus 9. Okay. Now, is x squared minus 9 in this form? Well, this has 3 terms. This only has 2. So it's not in this. Is it in this form? Well, it's got a number squared and it's got minus some number, right? Well, could 9 be expressed as a square? So we think, okay, x squared minus 9 x squared minus 3 squared. Recognize this as being in the form a squared minus b squared. A equals x and b equals 3. Special products. A squared minus b squared is a minus b times a plus b. Substitute x for a, 3 for b, and write this out. We'll do that. Here's the expression. Replace a by x, replace b by 3, and see what you get. Okay, now I was curious about this, but we're out of time, but I wanted to think about it for a minute. Okay, but we substitute x for a, 3 for b, we're gonna get x squared minus 3 squared equals x minus 3 times x plus 3. Okay. Now, you've seen videos that, go with this form as well. There might be another form in there somewhere. But the two that I really want to emphasize, which are the only two that get used a whole lot anyway, are these two. Okay, there's one for cubes. Yeah, if you see it, yeah, work it. There it is. I recommend, as always, that you write out your solution in the form that I've written out with words on it to reinforce what you're doing, rather than just doing it by habit. If you've done a couple of these, turn off your mind and you start doing it by rote. If you write out the words, you keep yourself focused on what you're doing rather than just routinely write down a bunch of numbers that aren't going to really penetrate your mind any more than they already have. Okay? So, recommend you write out an explanation of what you're doing, every problem in these homeworks. Okay? Because what I'm seeing is people come in to the midterm test and can't do what I've seen them do in class the day after the assignment. Okay? There's also the idea of reviewing the test. Something you probably haven't had to do a whole lot of in your life and takes a while to get to that. Okay, just advice. Get the homework done. We'll see where we go from there.